Hi, in this tutorial we are going to talk about how to scale earthquake recalls to match the target response spectrum, okay, in ETABS. Okay, let us start. I will just create a new model, select use built-in setting width, okay, and select metric MKS. Still section database will be as this one 15. Okay, still design code will be this 36016, and concrete design code is American Concrete Institute 31819. Okay, after that, okay, now I will just give some dimension for structure. For example, I want 5-story structure. Okay, in the story height will be like 3, and the bottom story height it will be 3.3 meter. Okay, so after that I want number of grid lines to be 5 in x directions and 4 in y directions, and the grid line the spacing of grid lines in x directions will be, let us say, 4 meter, and spacing of grids in y directions, it will be also 4 meter. Okay, after that click this one, grid only. Okay, now I will just define frame section. Okay, I will delete this one. Delete. Okay, okay, and okay, I will now define frame sections. Okay, and okay, press B. I would say 50 by, sorry, okay, and the material will be 4000 psi, and it will be 500 millimeters, and width is also 500 millimeter. Okay, and moment of inertia and axis 2 will be 0.35 and also 0.35. okay, moment of inertia about axis 3. Okay, modify show reinforcement. Okay, it will be beam in the same reinforcement. Okay, the top cover should be 40 millimeters and 40 millimeters. Okay, and okay, I will delete this one. Now add new property, click this one. I will select column. This column will be 50, also 50 by 50 centimeter. Okay, or 0.5 by 0.5 meter. Okay, the material will be 4000 psi. Okay, I will select this material, and the dimension will be 500 millimeters and 500 millimeter. Okay, modifiers will be 0.70, and this one also 0.70. okay, and this is also column. Okay, the same reinforcement material and rectangular, and this will be the clear covers, and other things will be the same. Okay, after that, okay, and okay, now I will just go and create columns and beams. Okay, I will just select column. Okay, select all stories. I will create this column, okay, automatically to be applied for whole building for each and every story. Okay, we have drawn the columns. Now it is time to draw them. Okay, now we are going to the main point. Okay, I will just define response spectrum. Okay, I will select the code American Society of Civil Engineering 716 code, and I will add new function. Okay, target response spectrum. Okay, and it will be 0.15, and this will be also 0.1. Okay, it is changing. Okay, and the long period will be 8. Site class will be B. Okay, and this will be automatically calculated by program or software like SDs and SD1, which is the response spectrum curves values. Okay, values, and the damping ratio is 5%. Okay, or 0.05. Okay, the 5% reinforcement, the damping ratio is defined here. Okay, or I want that much damping ratio. Okay, so after that I will just click OK. Okay, I will delete this one. Now I have defined response spectrum function. I will just click OK. Now I will go here. Okay, and I will just define what the time history function. Okay, before that I should have 2 earthquake records or 1 earthquake records in each and every directions. I will just have downloaded these earthquake records from peer ground motion database. Okay, so you can also check that video which is in the description. After that, first I will save this one, structure, in desktop, and will name thing 4 or 5 story. Here I will create. Okay, otherwise I will save here in this folder, and name will be this one. Okay, I will paste that earthquake records, or I have already here. Okay, I will paste this earthquake record here, and I will go here, define time history function. Okay, I will just define that earthquake records. Okay, I will browse, for example, this Kujali Maslak X direction. Okay, it has been attached. Okay, the lines to skip is 4, and number of points per line is 5, and the equal interval will be 0.0, 0.0 with C5. Okay, after that I will click OK. It will be added to the system. Yes, it is showing here. You have defined time history function or recalled in X directions. Now I will define the time history function in Y direction. Okay, here we have Y direction. It has been attached. Okay, it is lines to skip 4 and 5. And this one is 0.005. Okay, After that, okay. Yes, now we have defined the time history function for x in y directions. I will delete this one as well, this one. Okay, now I will just match the target response spectrum with this earthquake records. I will just go here and will select matched to response spectrum. Okay, after that I will add new function. I will give a name time history x direction. Okay, I will just select spectral matching in terms of time domain. Okay, and I will select the target response spectrum to be this one, and the earthquake records will be this one, x direction. Okay, so let me just revise first the target response spectrum. Okay, let us see, it is 1.15. Yeah, now it is okay. Please make sure I have revised some changes in this. I have just put it incorrect value here. Okay, after that I will just match. Go here, I will select matched to response spectrum, select this one, and after that add new function, time history x direction. I will select spectral matching in time domain. Okay, and I will specify the target response spectrum, okay, which I have defined. Okay, this one it is showing, and reference acceleration time history to be x direction. Okay, after that I will just select program determined. Okay, or you can do user defined as well. After that, matching time history. So it is matching time history process is going on. Okay, it has been completed. Now I will just match with y directions, add new function. Okay, I will give a name time history y direction and select spectral matching in time domain. Okay, and select target response spectrum and y direction and match. Okay, yes, this time history function and matched to a response spectrum in y direction has been completed. Okay, now I will just press convert to user defined, and we already just matched the earthquake records and to the response spectrum. Okay, after that, okay, yes, now I will just define the mass source, load patterns, and etc. Okay, I will just go here to define the load pattern, earthquake x directions, and seismic. Okay, the code, American code. Okay, and also x negative add. Okay, and y direction add, and y negative direction. Okay, so now I will just modify the load pattern. Okay, modify lateral load. Okay, I will just do do very quickly. And program calculated. After that, modify. Okay, 1.15, 0.51, okay, 8, 7, and program calculated, and 0.05, okay. Also in y direction, I will uncheck all these, okay, and I will just put here to be, and 7 program calculated, okay. I will just define negative, add, modify later load. I will unclick this one, and 1.15, 0.51, okay, 7, okay, yes. And I can also define mass source, modify mass source, okay. Specified load pattern, add dead load 1%, 1 or 100%, and live load will be 25%, okay. Add. After that, click OK. The mass source include both element self-mass and at least one load pattern with a self-feed amplifiers, okay. So I will remove this one. It's okay. Yes. Now, okay, everything is ready for the beams in column sections. Okay, now I will define the slab. I will go here, define slab section. Okay, modify its names. Okay, material is the same material, and I will just 180 millimeters. Okay, and delete this one. Okay, yes. Now I will just draw the beams or to this automatic. I will just assign for all stories. Okay, I will just do very quickly. Yes, the beam has been placed for each story. We'll just delete this one. Yeah, I will undo. Okay, go to the base, select one story, and delete these slabs. Okay, after that, select this base and assign the constraints. Okay, fixed, apply. Okay, yes. Now I will just assign dead in live load. Okay, select the slabs. Okay, after that, assign shell loads uniform. Dead load is 1.14444 kilogram force by meter square. Okay, replace existing loads, apply. Okay, get the previous selection. Okay, shell load uniform, this time live, and it will be 1.53. okay, apply. Okay, yes, you can check here both. Yes, these loads, dead load and live load, has been applied. Okay, after that, everything is ready. I will just go to start run analysis. Okay, so now the analyzation will complete and we will see the result. Okay, the main agenda of this tutorial was how to scale electrically codes to match the target response spectrum. Okay, and that purpose we have achieved, and additionally I have defined other structure sections and I have applied the loads and other things. Okay, now the analysis has been completed. You can check the analysis result and you can start an animation with others. Okay, thank you so much for your attention. I hope you subscribe this channel and press the bell icons for notifying you the most and recently uploaded lectures. Thank you so much. Have a great time.